Hello and welcome back. Today we've got a video on circles. So the equation of a circle has two forms. This form that I've written out already for you is the first form. There's some pretty important things that you need to know about this form. First of all, see this plus sign in between x squared plus y squared? That has to be positive. If it's not positive, if it's in the form of x squared minus y squared, then it's not a circle, it's a hyperbola. So it has to be positive. Second of all, see how the coefficient of x squared and y squared are the same number, they're both 1? That also has to be the case, because if it's not the case, the circle won't be a circle anymore. It'll become more like an ellipse. So when writing out this formula or applying this formula, you need to remember that x squared plus y squared, it has to be plus and the coefficients have to be the same, minus 2ax, sorry, that should be an x, minus 2by plus c is equal to 0. Now, from this expression, how can you figure out what the center and the radius are? So there's two different ways to solve it. There's one way that's much easier, so I'm just gonna start with that one. We're gonna start out by writing out the equation of this circle that I have, which is, let's see, x squared plus 4x plus y squared minus 6y plus 1 equals 0. So we can rewrite this to put it in the form of this, which would be x squared plus y squared plus 4x minus 6y plus 1 equals 0. So if we compare this formula right here with this formula right here, we notice a couple things. They're very clearly pretty similar, right? So we've got an x right here. We're going to try and compare them to find what the center and the radius is. We've got an x right here. By identification, we can use this x right here, meaning that 2a right here, or minus 2a, sorry, minus 2a equals to 4, because the coefficient of the x needs to be the same, which would then be a equals minus 2. We can do the same thing for b, so minus 2b equals, here we can see the b's in front of the y, right? So we take what's in front of the y, which is minus 6. So b is equal to 3. And then c, this one's pretty easy. It's just whatever's left over without an x or y. In this case, it's 1. So c equals 1. So now that we've identified all the different parts of this expression, it's pretty easy to find the center and the radius. So the center of the circle is simply a, b. So in this case, the center of this circle right here that we have is minus 2, 3. And then the radius is equal to the square root of a squared plus b squared minus c, which in this case is minus 2 squared plus 3 squared minus 1, which comes out to radical 12, which I believe is 2 radical 3. So from this expression, we found the center and the radius. Now there's another way to solve it. This way's faster, but the other way you can solve it is by the method called completing the square, which we take the expression, I'm gonna write it back out for you, x squared plus 4x plus y squared minus 6y plus 1 equals 0. And we just complete it by solving the square until we get another expression, which is going to have x and a value squared plus y and a value squared equals a value. And from this, we derive our next expression, which is, page for you, x minus a, all of it squared, plus y minus b, again squared, equals r squared. So this is the second general expression of a circle. And finding the center and radius from this is really easy. Center is AB and radius is R. So let's take this as an example. In this expression, x plus 1 squared plus y minus 3 squared is equal to 25. Center is AB, which is A is this, so center is minus 1. B here, in this case, is 3, so the center is 1, 3. And the radius is equal to the square root of 25, which is 5. So it's a pretty quick expression, but one thing we can do, we can go back to this one right here and try and transform it into this form so that we can take the center and the radius from it. Let me just write that out. 1 second. Let's see, what was it? X squared, that should be a 2, plus 4x plus y squared minus 6y plus 1 equals 0. So we can then solve it by completing the square to get x squared plus 4x. If you haven't learned completing the square, go watch my video on quadratics before you solve this. But I'm assuming if you've gotten to this video, you should know how to solve by completing the square. So in either case, 4 divided by 2 is 2, so 2 squared plus 2 squared minus 2 squared plus y squared minus 6y. 6 divided by 2 is 3, so plus 3 squared minus 3 squared plus 1 equals 0. Just bring this all together. We can see that this part right here reminds us of a remarkable identity, and this part right here reminds us of a remarkable identity, which is x squared plus, no, not x squared, sorry, x plus 2, all of it squared, plus, let's see, y minus 3 squared. And then we just move all of these over. We get 4 plus 9 minus 1. So then we have x plus 2 squared plus y minus 3 squared equals, what number is that? That is a 12. So we can then go back to this up here. We can find that the center is A, which is minus 2, and B, which is 3, and the radius is radical or root 12, which is, I believe, what do we say? 2 radical 3. So if you look at this really quick, you can see center minus 2, 3, and radius is 2, 3. Compare it to this. You see that we got the same answer, and it just depends which way you prefer, because they're both pretty easy once you get the hang of it. Now, there's a couple important rules that you need to remember. First of all, a squared plus b squared minus c has some pretty important implications. In the first case, if it's less than 0, then there's no circle. The circle's impossible. If it's equal to 0, then we have what's called a point circle, where the circle is just a point. If it's greater than 0, we've just got a normal circle with a radius of square root of a squared plus b squared minus c. I'm pretty sure that that's everything that we need to talk about circles. Now we can move on to the relative position of a circle and a line, which is pretty easy once you learn it. So the relative position of a circle and a line is essentially, where is the line in relation to the circle? Is it outside the circle? Is it touching the circle at just one point? Or is it intersecting the circle at 2 points? Ignore my horrible drawing of a circle. I am not an artist. So in the first case, if it's not touching the circle in any way whatsoever, what we need to do is find the distance from the center to the line, or to a point on the line. If this distance is greater than the radius, then we can say that the line is exterior to, let's call it circle C. Now, if you take the distance from the center to a point on the line, and the distance and the radius are equal, then this line is tangent to the circle. So it's a line tangent to circle C. If you get the distance from the center to the point on a line, and it's less than the radius, so distance is less than the radius, then there's two different things you can call this. You can call this line secant to C, or you can say that it intersects C at two different points.